to the second tutorial in this series. So this is where we left off last time, and in this video we're going to finish up this project. But to start, we'll assign different colors to different hexagons, but we can't work on just one canvas or else it'll be very resource consuming. So to fix that, we're going to create one canvas for user interaction, one canvas to hold our background colors, and another canvas to hold our obstacles. So let's get started by creating the canvas that will be responsible for handling our mouse movements and clicks. When we have Atom opened up, also make sure that our X and Y are at 400 and 300 respectively right here. And let's go down into our render function and write this little bit of code underneath our canvas hex. We'll start by saying canvas, give that a closing brace, and inside here we are going to write. Okay, so this is our canvas that we are going to use to essentially interact with the user or show the user's interaction with a canvas. We also want to create a method here called onMouseMove, and we will go and create this handle mouse move in just a second. But now if we hit Control S, let's go back to our page, and we see our new canvas is right down here, so that's good. Now we have to align the canvas with our other main canvas. So let's go into first bfs.css, and we are going to write this. Okay, now our position is absolute and we've assigned left to 0, so when we look inside of React, we see our canvas right here, and now we have to adjust the width and height so it perfectly aligns with our other canvas. Back into BFS, we will simply go up to component did mount. Right here, oops. Right in here, we will initialize our width and height of our new canvas. Okay, now that we have initialized our height and width, it looks like we have perfectly outlined our other canvas. Now let's go into our component did mount, into our constructor, and we are going to bind our handle mouse move method. Okay, so I was getting a little ahead of myself trying to write the handle click method, but we're not going to do that quite yet. Let's hit Control S on this and go down, scroll down all the way and create this handle mouse move method. Okay, let's hit Control S, take a look at our screen here, and we will open up our console. I believe right click inspect, move to the console. Okay, so we see that as I move around, my mouse is being tracked and the coordinates are being printed in the console. Now the problem is that yes, we are starting from 0, 0 in the top left right now, but we need to be able to start from 0, 0 in the top left wherever the canvas is on our page. So let's go and create a getCanvasPosition function that will essentially always return us the position of the canvas in order for our starting point to be 0, 0 up here. So underneath our handle mouse move, we will type the following. Okay, so basically we're just setting the current state to wherever our canvas is. So in that way we're always getting the correct canvas position. Now let's go up in our component did mount and call this function. So inside component did mount, right underneath this constant variable, we can type the following. And actually, we will bring this down below right before our draw hexes call. Okay, so this is looking good, and now let's go inside of our handle mouse move E right here and type some code in here. So basically what we're going to do right now is just get the left, top, bottom, and right of our canvas through using our canvas position up top. Okay, so we've gotten our canvas position from the state, and our offset X and Y will help us determine where the canvas is despite its position on the page. So now let's hit start here, and we'll open up the console. Okay, so we have our coordinates, and yes, we are looking at 0, 0 in the very top left, so that's good. Now, if you aren't getting 0, 0 right there, there's a little bit of other calculation you can do when recording the offset. So be sure that you check my code in the description if you want to move the canvas around the screen, because this method will vary slightly depending on where the canvas is. So yes, be sure to check that code, and let's move on to the next part. Now we have our coordinates on the canvas, but we need to convert the coordinates to a hexagon so we know which hexagon we need to light up based on where our mouse is. So back to our nice handy website, we are going to use the pixel to hex function. Pixel to hex. Okay, so we will copy this right here, and we are going to paste this in Atom. We can just paste it right under here. And now we are going to change this function, or I'm going to change this function, and we'll talk about it in a sec. So this is our new pixel to hex function, and you see I've created the size and origin variables. We've also changed a little bit of math here, which include adding p.x and p.y and origin.x. We also added math.square root, and make sure that you guys aren't caught up on these braces, and that will throw off your code if you don't have it correctly. We're also returning this.hex. However, we have a new addition here, which is going to be our s variable. So we're returning our columns row in the s variable, which is going to be another indicator of where our hex is on the screen. So now let's go up to our hex quick and change this. We'll just add the s variable here. Okay, so we're all good to go with that, and now let's go into our handle mouse move, and we're going to add some code. Okay, so we're all done here. Now there's a few things to note. We are going to get our column, row, and s value here from the offset x and y. However, we do need to create this cube round function, which will round these values accordingly. Now we also created our x and y variables, and we're drawing hex right here. But if you notice, I've added two more arguments onto the end, which is going to be the color that we're going to draw the hex, or the color that the hex is going to be, as well as the width. So around the hex, around the border of each hex, there will be a green color with a width of 2. Now we're also setting the state right here so we know where our hexagon is, and we can also go off the next state. Now let's go in and create our cube round function, which our handy website will show us. So this cube round function, we are just going to hit copy, go back to Atom, and we'll paste it right under here. Now I'm going to change this code up a little bit, and then we'll go from there. Okay, so this is our new cube.round function, and you see that we've added math.round here to these functions. We've also changed x, y, and z to q, r, and s. We did q, r, and s for here as well. We put some brackets and braces around our if statements just to make them look better, and we're returning this.hex. Now what we have to do is go into our drawHex coordinates function and make it abide by our new variable s. So if you notice here, I have changed these values, and that's just to position them differently inside of the hexagon. So let's create this next line. Okay, this is all good to go now, and we also have to add our s variable into our drawHexes method right here, and all we need to do is just go after this and type minus q minus r. Okay, and we'll do the same thing for this, minus q minus r. Alright, that looks good. And now let's highlight the current hexagon with the green colored line. And to do that, we need to go into our draw line method and change a few lines of code here. So right here, we're just going to add the following. Okay, We're all set here. All we did was add the color and width, basically the width of the line that will be drawn around the hexagon and the color. Alright, so now let's go into our draw hex function and change this finally. So right here we just have to account for the color and width as well, and we will add this code. Alright, let's hit Control S. And so now with the code that we have, it's basically going to highlight every hexagon that we scroll over and not unhighlight it when we go to the next state. So what we need to do is add a method called shouldComponentUpdate, and this method is going to compare our current hexagon and the next hexagon, and if our mouse pointer is not moving, then the current state and current hexagon and next state and next hexagon will be the same, but if we move the pointer, then it will change, thus only highlighting one hexagon. So that probably didn't make a lot of sense, but let's just go into this shouldComponentUpdate method and let's take a look. Underneath our component.didMount, we will create this method. Okay, so let's hit Control S, and basically what we did here is, like I said, if our hexagon, when we're scrolling over the hexagon table, it's going to illuminate any hexagon that we scroll over, but it's not going to eliminate the hexagons that we've already scrolled over, if that makes sense. So we just want one hexagon illuminated at all times. So this method is basically helping us do that by creating a next state. So if we do have the next state and we're scrolling to another hexagon, we're going to clear the board of the rest of the hexagons essentially. And you can see that like right here, we're clearing rect, and then we're drawing our new hexagon. So let's hit Control S again and go back to our board, and we see that we're drawing our lime hexagon perfectly, and all of our coordinates are being printed out. And you see that when we go over the 0, 0, 0 hexagon, it's printing our coordinates over in the right, our Q, R, and S value. So this is perfect, and let's go back here and make sure that you have this inside of the handle mouse. I was just printing Q, R, S, X, and Y right here, and yes, we are all set. Now let's go to the next part. Okay, so next we're going to draw the neighbors of our highlighted hexagon, and basically a hexagon has 6 sides, so we're going to have 6 neighbors. And to do that, we're going to use this cube directions functions. But first, if you notice here that we actually have the wrong numbers on our hexagon. So we have our 0, 0, and then we have 2, -1, 0, but right here it's 0, -1, and +1. So let's actually fix that real quick. We'll go and open up Atom, and inside of our draw hexes function, we need to change this line of code right here. Draw hex corner coordinates, and instead of what we have, we are going to change this third argument to. Okay, so we just changed this to -q minus p here and -q plus n right here. So let's hit Control S, go back and check. And we see that we have the right numbers here. However, they're just in different positions compared to over here. So we're looking good, and now let's create this cube direction function. So I'll copy this, go and paste it into Atom underneath here, and we're going to change a little bit of this code. I'm also during this time going to make a cube add function that will essentially add up all the neighbors that we get until our final cursor point. So like say we have our 0, 0 hexagon here. When I move the cursor to -11, 11, what's going to happen is the cube add function is going to add up all these hexagons so we know how many are in between in our path. Okay, so this function will return the addition of all of our hexagons up until our mouse cursor. Now let's get make the getCubeNeighbors function. Okay, and this will return our neighbors. Now we need to draw the neighbors for all 6 neighbors of our hexagon. So let's make this function called drawNeighbors. Okay, so our neighbors are going to be of the color red now, and we're just using our constants here to get the neighbors, and subsequently we're drawing the hexagon right here. So let's now call this function in our should component update. Okay, so in should component update, right above our draw hex, we will call this function. Okay, let's hit Control S and look at our canvas. Okay, so we have an error here. I had a mistype, so scroll down and right, where did that say? 214. Get cube neighbor. Okay, right here. Okay, so let's check our canvas now. Control S. And we have another typo. So it's in here and we need get cube directions. Okay, so let's hit Control S now. And we see that we have our neighbors wherever we are scrolling. So that's good. And now the next thing we have to do is create a function that's going to help us calculate the distance between the hexagons and draw that distance by highlighting the intermediate hexagons in the path. So in the cube distance function on our site here, we'll look at cube distance. So in this function, we see that we need to actually subtract our hexagons here. So let's make a function called cube subtract really quickly, and this will essentially be the opposite of our cube add function. So underneath draw, or actually underneath cube add, we'll make cube subtract. Okay, so now that we have our cube subtract function, let's make the function that will actually calculate our distance. So this will be called cube distance, and it's on the website, so feel free to check that out. Okay, so now let's go to our should component update method, and we're going to comment out the draw neighbors since we don't need it anymore right here. And also we can quickly add the gray color to our board and draw hexes. So right here we're just going to add gray, and down here further we will add gray. Okay, and now let's find the path between our hexagons using linear interpolation. And that sounds like a lot, but it's actually very simple. And the method for linear interpolation is on the website. So if we go back to that and we look for the lerp function. So basically right here, this is what we're going to be using. And now let's copy this and paste it in Atom. And I will change a few things here. Okay, so this is our linear interpolation function. You can definitely read more about it on the website, but we're going to skip all the syntax for now. And now let's add another method to pass our columns and rows into our linear interpolation function, and this will be called cubeLinearInt. Okay, so this is going to be passing all of our hexagons into the linear interpolation function, and that's further going to do our calculation here. Now we need a function called getDistanceAlign, and this function is going to find the coordinates of each intermediate hexagon. It's going to store them in an array, then it's going to draw them on the canvas. So here we go. Okay, so here we go with this. And again, I'm going through these functions very fast, so if you want a greater explanation, feel free to look at the descriptions on the Hexagon site that we're using. So now let's add this method to handle mouse move and see what it does. So inside of handle mouse move, we are going to, first we'll erase this console.log, and we'll replace it with, okay, so let's hit Control S here. Open up our canvas. And now let's see, so from our point 0, 0, when I move over to the 11 mark, then let's check that. So inside of our object, we see that we have our first hexagon, second, third, and all the way up to 11. So we're definitely getting the path over to our 11th hexagon. So that's good. And now let's draw the line that we got in should component update. So right here underneath our ctx.clearRect, we're going to write the following code. Okay, so we'll hit Control S there, go back to our canvas, and we see that is now working perfectly. We have our line starting from our origin to wherever we want to move it. But now see that when we go over here, we're out of bounds. We're basically our current hexagon is going beyond our canvas. So let's create a condition that's going to fix this. And back in our atom, this condition is going to be from draw hexes, and I'll rewrite it here in the handle mouse function. Okay, so this is basically just the same function that we saw before to keep everything orderly. Now, after hitting Control S, let's go back and check. And it looks like we are still highlighting green down here, so that means right here, this draw hex, we'll just get rid of this. Click Control Save, check again, and we seem to be all set. Alright, on to the next part of the app. Okay, now let's look to fill the hexagons with color and start creating our ability to move the starting hexagon around the canvas. So let's first comment out the draw coordinates inside of our draw hexes method to make the board look a little bit nicer. So we'll just comment this out right here and right here. Reload that. Okay, this looks good. Now let's get rid of the border too. Get rid of this. And the app looks good now. Okay, so now what we have to do is create a function that's going to fill the hexes with color. So to do this, the canvas attribute doesn't have a method already, so we're going to have to create a draw lines method between all of our hexagons. So what's going to happen is that we are going to take each hexagon, and for its neighbors, we're going to draw for a line from this corner up to here, from this corner to this corner, this corner to this corner, and then in between the lines, we're going to fill the hexagon with color. And we're also going to make the lines that color too that we're filling. So let's go over and do that. Now we're going to create a method here called fillHex, and we'll just create it at the bottom here, and we have fillHex. Okay, so this is our fillHex method. Now let's call this in the drawHex function before the drawLine function. So in our drawHex function, now right before we say drawLine, we are going to call this fillColor. Okay, and now we also have to add onto here, we are going to add the fillColor. And let's also change this color here to line color. And we also have to change this to line color. Line color, and we can get rid of these and just simply replace them with start and end. Okay, so this looks good now. And now let's go and change the color in our draw hexes method. So right here we have our gray, but we're actually going to change this to say this.draw hex xy, and this is going to say black, and we'll give this a width of 1, and we'll do the same for this. Okay, that looks good now. And our next order of business is to change the color in our should component update method. as well as highlighting our starting hexagon in the current distance line. So inside of our component, or should component update, we have to make the following changes. Okay, so this looks good now. We'll hit Control S, take a look inside of our canvas, and we see that we have just what we need. The red in the middle, and we are still able to move around. Okay, so now let's create a click handler to move our position around the canvas. And to do that, we need to go down to our render, and we're going to add right in here an onClick method. So I'll just actually enter this so you guys can see. And this is going to say onClick equals this dot handle click. Okay, so we're good here. And now let's create this handle click method right here. And let's go up and bind it in our constructor. So we'll say this dot handle click equals this dot handle click dot bind this. And inside of our handle click method, we're going to write this code here. We can get down here. We're going to set our state. And we're going to create a position in here, and we'll call this player position. And set it to our current hex. Okay, and now we need a default state for our player position and our current hex. So in our constructor, we will add this code. Alright, this function is looking clean now, or sorry, our state initialization. And now we need to add the coordinates of our player position into the getDistanceLine method. In that way, in our handle mouse move method, we can delete the old getDistanceLine. So let's go do that. And inside of here, we are going to take this old getDistanceLine and we're simply going to insert this .hex, but we're going to pass the parameters player position.q and player position.r, as well as player position.s. Okay. Now we're all good here. Let's show this. Let's see if we're working. Player position is not defined. Okay, so we actually need to simply just add this line of code. Let player position equals this dot state dot player position. Okay. Let's save that. Check out, and we're looking very good. And see, we can move around now. So this is great. Now let's go on to the next part, which is drawing our obstacles. So let's first actually refactor our canvas down here, and we're going to refactor canvas coordinates here to, let's see if there's a refactor option. Actually, I believe we can Control F, canvas coordinates, and we'll replace this with canvas interaction. And this is because the canvas coordinates, the canvas hex and the canvas coordinates, they're basically not frequently redrawn. So it's going to be a lot of processing power to do it how we are currently doing it. So we're going to create another canvas and call it canvas interaction. So we're going to go around and replace all of our canvas coordinates here. Okay, and we're all set. Now let's create another canvas that will be called canvas coordinates. Alright, and now let's go back to our our handle mouse method, handle mouse move, and just change this back to 0, 0, 0. We don't need player position anymore. Okay, and in handle click, we can erase this code here. And now we'll go and add our obstacles in the constructor, and we don't need the player position anymore. So we can go ahead and erase this and simply just type obstacles, and we'll leave that open like that. Okay, now let's create this add obstacles function so we can go about and start adding our obstacles. We'll come down here under handle click. Okay, so this is our add obstacles method, and essentially we're just taking the coordinates of wherever the user is clicking and we're adding it to our array of obstacles, and then in a subsequent method up in our show component update, we'll actually draw the obstacles of our array. So inside of our handle click method here, we need to call this function, so we will simply say this.add obstacles. Okay, so now let's go and draw these obstacles. And basically, we're going to go inside of our should component update method and cycle through the array of obstacles that we created in our add obstacles method. So right here underneath our for loop, we will write this following code to draw our obstacles. Okay, so now this should be working just fine, but let's actually, since we have some time, let us go inside of our draw hex method and just change these arguments just to clean things up a little bit. And also, I believe that we need to change this value here, the current distance line dot length, to 2, or subtract 2 from that. So make sure you get that. And let's go into our draw hexes method and actually clean some of this up so it just is a little bit neater. So we're going to change these parameters or arguments to, okay, so we just changed these to line width, line color, and fill color. We also have to change down here for our draw line function, and then we can simply just change these parameters in our draw line function to line width and line color. Also, don't forget to change these two variables right here to say line color and line width. Okay, so now that looks good, and we need to change our spots where we're creating our hexagons of color here to basically um, match our new arguments. Okay, so here we go. Okay, so now that these are all changed here, let us save this and check out if our app's working. Okay, we have a little typo here. Okay, save that. Okay, so we see that the app is working just fine. We're placing our obstacles. We can also take them away. But let's actually make the color of our obstacles black instead of gray just so we can see them a little bit better. So we'll just change this value right here to black. Save that. And it looks much better now. So I don't want the video to go too much over 30 minutes. I think I will just end it there and make a short third video that'll be about 15 or 20 minutes, and we'll finish up this app. So don't forget to hit like and subscribe. I will see you in that video, and thank you very much for watching.